Assalamualaikum warahmatullahi wabarakatuh. Hi guys, welcome back with me in the same chapter, Geometric Shape. In this video, we're going to understand the very important concept about circle. In everyday life, we find so many things in the form of circle. For instance, pizza, wheels, and clocks. All of them are in circle form. But before we talk deeper about that, let's find out the parts of the circle. First is the center of the circle. Then the radius is the distance from the center of the circle to its outer rim. Next is a chord. It is a line segment whose endpoints are on a circle. Diameter is a chord that passes through the center of the circle, and the length of the diameter is 2 times the length of the radius. Next is secant, is a line that intersects the circle into 2 points. And tangent is a line that intersects the circle in exactly 1 point. Well, let's have a look at this part. Pretend that you have a pan of pizza, then cut a piece for yourself. And you cut again in secant line. So, if this is a circle and I cut it along 2 radius, separate this part, it's called a sector. But if you cut it in a chord line, it creates a segment of the circle. Now, how to find the area and the perimeter of the sector and the segment of the circle? But before we find those things, let's understand the very important concept about circle. In the previous video, I have explained about the area of the circle, and this colored part is a half of the circle, so the area would be half multiply the area of the circle. This is the area of the circle. And we multiply with a half to find the area of these colored parts. Now look at this circle, which is divided into 4 equal parts. The area of this colored part would be 1/4 multiplied with pi r squared. Pi r squared is the area of the circle. While 1/4 is the area of the colored part. Now let's look at another parts of the circle. So, what will be the area of the colored part in this case? Without any information, we cannot find the formula of the area of this part. In the first case, the angle is 180 degrees, and the area is 180 by 360 times pi r squared. This value is the same with this value, as the ratio equal half. Similarly, since the sector angle is 90 degrees in the second case, the area of this sector is 90 by 360 times pi r squared. In the third case, if the angle is 30 degrees, we use the formula the sector angle by the circle angle times pi r squared. So 30 by 360 times pi r squared. If we name the angle of the sector by x, then we generalize the formula of the sector area is x by 360 times pi r squared. Now, how to calculate the perimeter of the sector? But before we find the perimeter of the sector, first we have to find the length of an arc. Remember that arc is the smaller parts of the circumference. Perimeter of the sector here is made up of arc length plus radius plus radius. For instance, if we call the sector angle here is theta, so arc is theta by 360 times 2 times radius times pi. This is the perimeter of the circle. If the sector angle is 60 and the radius is 7, we substitute and the arc is 7.33. Then the perimeter of this sector is radius plus arc equal to 21.53. Now we move on to the area and the perimeter of the segment. Segment is a part which is cut from the circle by a chord, a line between. The area of the segment is the area of the sector minus the area of the triangle. If the theta is 90 degrees and the radius is 7 cm, then we substitute to the formula. Then we have 38.5 for the sector area and 24.5 for the triangle area. And the segment area is 14 cm squared. Now, how to find the perimeter of the segment? The perimeter of the segment can be found by adding the chord line and the arc line. Just substitute and calculate them to the formula. Then we have 0.061 for the chord line and 11 for the arc line. It's equal to 11.061 centimeter. Now let's move on the circle geometry. Angle at the center and angle at the circumference. Now, if you have circle, a center angle is the angle formed by the center of the circle and 2 points on the circle. And remember that the measure of the arc PQ that is intersected is always the same measure as the central angle POQ. And if we connect them to the points across the central like this angle connected PRQ is called inscribed angle. And remember that the inscribed angle is always half the measure of the arc. So we can conclude here, central angle is 2 times inscribed angle, while inscribed angle is half times central angle. Well, let's have a look at this example. For instance, if the central angle of POQ is 90 degrees, the inscribed angle is half times the central angle. So inscribed angle PRQ half times 90 degrees is 45 degrees. Now, what if you have a circle and the arc that you are thinking about is actually a semicircle? Then draw an inscribed angle on that. Because semicircle is 180 degrees, so this inscribed angle has to be a right angle. So in general, inscribed angles in semicircle are always right angle. Next, if you have a circle and you pick 2 points in the circle to make inscribed angle form, there are infinite number of inscribed angle that you can draw from those 2 points. For example, you can have an angle down here, or you can have an angle over here. Then you can see you can keep going and you can create more and more inscribed angles. If this arc is 90 degrees, each of these angles would have to be 45 degrees, half of the arc. Because all those inscribed angle intersects the same arc, it means they are all must be congruent. Now, if we have a circle and mark it in the center, then draw 2 tangents to the circle from given points outside the circle. Then draw a line from the center O to the point with the tangent stop the circle and label this point A, B, and C. We know that OA equals OB because they are radii of the circle. We call this length X. If we connect OC, we create 2 triangles. We can call the length of OC with Y. We know that they are right-angled triangle from the circle theorem that states where a tangent meets a radius, the angle between them is always 90 degrees. So now we can use Pythagoras to calculate the length of BC, because we know the length of hypotenuse is the length y and one of the sides is the length x. So BC is equal to square root of y squared minus x squared. AC is also equals to square root of y squared minus x squared. So AC is equal to BC. From those explanations, we can conclude that two tangents to a circle from given points are always equals in length to where they touch the circle. Those are the explanation about circle geometry concept. See you on my next video, and wassalamualaikum warahmatullahi wabarakatuh.